Hi everyone, Leah here. Today I'll be talking about my solution of day 7 of Advent of Code 2023. This year I did it in Haskell, which has yielded me a lot of solutions that I didn't think would be this beautiful. Um, Partly because of some really nice properties that my end solution uh, eventually got that isn't that portable to other languages. So here we have my test suite of all of my different cases, my classified um, um, hand kinds, and also I have tests for comparing hands of um, mostly the same kind but different starting um, cards so that they compare differently. I also have part 2 here with the Joker, and I use parser combinators to parse a line. So here is a line. It's separated by new lines, and it starts with the cards. Cards is just a bunch of characters from this pile, separated by a space, and then a number. This is our bet, and I concatenate that to get into a tuple, and then I sort them. The sort part is actually where the magic happens. This is sorted based on the hand, of course, and then this is zipped together with a rank, which starts from 1 as the problem dictates, and I just multiply the rank and bet together and sum them up. So that's how I do the thing. The most important thing, of course, is that I have a sorting algorithm. So how does that work? So when I jump down below, I use the new type to model my hand. It's just a bunch of cards. I made the card generic because part 1 and part 2 have different criteria, and I have to using a generic type makes the most sense to me, and it's also very flexible, and I can use a type class like that to do what I would needed to do. And here you can see that my implementation of ORD, which is what gives the order, is simply comparing the hand type and then using the semi-group um, the operation associated with the semi-group of ordering, which in the case of ordering, which is just do the first comparison. If it's a tie, it's EQ, and then use the second comparison. I find this function like absolutely beautiful, and like I find it baffling that other programming languages don't have this feature, and say in a lot of the cases you have to hand roll your own comparator. You have to go from if some a dot something is smaller than b dot something, then -1, else if a dot something is bigger than b dot something, then 1, else then compare a dot b, b dot b, something like this. You don't have to do any of this in Haskell. You just have to do comparing function, comparing function, chain them together. Very nice. I love this kind of chaining that makes actual mathematical sense in Haskell, and I love it for it. Yeah. So now you can see that we have a defined compare function, but then we have to get the hand type. The hand type algorithm I find is also quite cool. So here I devised a length of groups function that's different per the card type. And so for the part A, you can see that length of groups prime, which is the default implementation, I have a very clean, point-free solution here that first sorts the cards and then groups them together. You have to sort them first because group only groups together adjacent elements, and so you have to sort them first in order. The cards have a defined sort order as defined here. It's what the problem dictates, so you can see that A is bigger than K, is bigger than Q, is bigger than j is bigger than t, and for the digits, it's literally I just got the digit and sort it like this. Card B, like for part B, it's the same, except that the joker obviously has a priority of 1, which is lower than 2. Yeah, so that all makes sense. And then it's sorted and grouped and mapped to its length. So for example, if you have something like Q8 JQQ, and then when you sort it, you get into AJQQQ, pair Haskell's default ascending order, and then you map that into length, so 1, 1, 3, and then you reverse sort it, so 3, 1, 1, and now you have the length of all of the parts. And so the first one, it's going to determine what kind of types this hand actually is. So if it's a 3, you know it's either it's a 5, then it's definitely a 5 of a kind. If it's a 4, then it's definitely 4 of a kind. If it's 3, it can either be so if it's a 3-2 situation, then it's definitely 3 in a pair, so that's a full house. If it's a 3-1-1 situation, then it's a 3 of a kind. And if it's a 2 and it's 2-2-1 situation, then it's 2 pairs. Then it's 2-1-1-1 situation, then it's a just 1 pair. And then if it's 1, then you know it's all ones. So it's how is it called again? Yeah, high card. So this is exactly what I did here. I matched on the head. It's 5 of a kind for, I just described it. And depending on the second element, if it's a 2, then it's full house, or it's a 3 of a kind. I just went through all of this logic, and I find it very fascinating that with this approach, you only have to compare the first 2 elements. And that's it. That's all you need. That's all the information you need to get the hand type. And since the hand type, I laid it out in ascending order as well, so this just works. I don't have to fiddle with order or anything. It just works. And comparing cards, it uses the cards as sorting order, and so that also works perfectly. I don't have to hassle with anything or implement my own comparators. Well, I kind of already do, but like I implemented them with ORD with this awesome type class. I don't have to extend anything. I don't have to write special dunder functions or anything. It just works. It works very intuitively, and I love it so much. And yeah, that's pretty much my solution, except for part B, where of course with the jokers things get a little bit more complicated. My solution basically boils down to dividing the initial card pile into jokers and non-jokers with a simple criteria, and then I grab, because in order to make the most value out of it, you need to like get the you need to get the most common card in the non-jokers pile and turn all of the jokers into that card. So say you have like again the QQ8 QA situation, and then you have 2 jokers and 2 queens and an 8. The most common card here is the pair of queens, so both of the jokers are going to turn into queens, and then you get a 4 of a kind. So that's essentially what I did. I also used the length of group algorithm on the non-jokers, and then I got everything with the rest. And then the first one, I used list to maybe from maybe pattern to avoid it crashing if it's a 5 of a kind, or is it? Yeah, I forgot. But like basically, it's yeah, no. This is not using head, because there's a, if it's all jokers, then length is gonna be empty, and you don't want that. So just to use the safer way, use from maybe list to maybe, kind of clunky, but I know I should probably be using reload instead of this, but whatever. And for drop one. Drop one, it's safe if it's empty or only has 1 element. It will just give you an empty list. So this won't crash, this is total. So that's pretty fine and dandy. And all you have to do, because it's already in lengths, I just have to add the length of the joker, and then everything is all set. Everything is very, very much fine. And now down here, the same logic, and then the same parsing logic, and then the same sorting, the same zip, and the same sum. It all comes together, and I also included the examples, they were just fine, and for my final solutions, there should be 2, for the given input, 2520, 520 to 80, 2528, 98370. yeah, so I've written a bunch of cases to check all of these, and yeah, it just works beautifully. Um, Thanks for listening me explaining this, I guess. Haskell is really a language that fascinates me. Once I really got into like the mood of what I'm supposed to be doing, once I've gotten a lot more used to the functional paradigm, um, all of this just works, and I can write out solutions that work better, more reliably, and sometimes even faster than imperative solutions. And what is a constant though is that it's almost always going to be a lot more readable than imperative solutions, because in imperative solutions most people would probably write a lot of loops for this and write a lot of ifs. I don't think there's not a lot of ifs in this, and so yeah, it's gonna be a lot more readable, a lot more compact to be sure. Um, I don't have to do pops and pushes and something like that. Um, and also, like, writing point-free solutions just generally makes me really happy that a chain like this can exist. And yeah, that's pretty much it. Um, I hope you enjoyed my solution, and see you soon. Bye.